This video is on solution stoichiometry. You're going to use what we already know in terms of conversions and stoichiometry and a balanced reaction, but now we're also going to add in the fact that we can use concentration as a conversion factor. So things you already know, grams to moles, that relationship is that 1 mole equals your molar mass, right? And this is from your periodic table. You should be able to do this quickly and easily. When it comes to particles like ions, atoms, formula units, molecules, like really, really tiny things, 1 mole equals 6.02 times 10 to the 23rd of whatever you have. I'm just going to write particles, right? And that's Avogadro's number. When it comes to gases at STP, so standard temperature and pressure, we can use what we call molar volume. And 1 mole will equal 22.7 decimeters cubed. Otherwise, if not at STP, we can use, right, the ideal gas law. And then what's new today is if you have volume of a solution, because here we can use concentration as a conversion factor because we've got moles over volume. So I'll show you what I mean by that. When it comes to a conversion factor with concentration, when you have something like 6 moles per decimeter cubed, right? Or if IB likes to write it like this, you can write that as 6 moles per 1 decimeter cubed, or you can flip it over, 1 decimeter cubed for every 6 moles. And you can set that up either way to get your units to cancel. So if you're trying to convert from moles to volume or volume to moles, you can do it this way. So let's do a problem. So it says, based on the reaction given below, which we'll write out together, how many centimeters cubed of 0.275 molar or moles per liter hydrochloric acid are needed to react with 10.0 grams of MgCO3. So our reaction, we've got hydrochloric acid and magnesium carbonate. If it says react with, I'm going to need a reaction before I even think about the numbers. So carbonates break down in a certain way. Whenever you get a carbonate like this, you're going to get water and carbonate with an acid, you're going to get water and carbon dioxide. So think of this as double replacement, where you're going to get, I'll write it, H2CO3, plus 1 for hydrogen, minus 2 for carbonate, and magnesium chloride would be MgCl2. But what really happens is this breaks down into water and CO2. So my actual reaction is going to be, I'll write it in black, would be HCl plus magnesium carbonate will make magnesium chloride, water, and CO2. All right, and we'll do more practice with these carbonate reactions like this. Okay, so now let's see, let's balance this, which would give us a 2 here. All right, so then now I can look at what it's asking and what I'm looking for. So how many centimeters cubed? So we're looking for a volume. We've got a concentration of HCl, and we've got a mass of magnesium carbonate. All right, so if I have concentration, right? Concentration is moles over volume. I need to find moles in order for that equation to work. So I need to find moles of HCl. Okay, so if I'm trying to find moles of HCl, how can I get them? Well, what else do I have? I have 10 grams of magnesium carbonate. If I have a mass of anything in this reaction, I can find mass or moles of anything else. Right? Because I can use my my molar mass for grams to moles, and my mole ratios because I have a balanced reaction. So I can go grams to moles of magnesium carbonate, and then I can convert that to moles of hydrochloric acid, and then I can convert that to volume using my concentration equation. My concentration as a ratio. So let me show you what I mean by this, and I'm going to do this in one problem, like one big step. All right, so I have 10 0.0 grams of magnesium carbonate. Okay, first step, convert it to moles. So grams, I'll need to divide out per 1 mole. And I do this molar mass work from the periodic table, add it all up, I get 84.32. Okay, so grams of magnesium carbonate have divided out. All right, so now let's convert moles. So there's 1 mole of magnesium carbonate for every 2 moles of HCl. So now those have divided out, and I've converted to moles of HCl. Now I can convert to decimeters cubed because that's what my concentration is. So my concentration is this 0.275 moles per decimeters cubed. And I want the moles to divide out. So I'm going to put this 0.275 moles on the bottom and 1 decimeter cubed on the top. So what I've just divided out is moles. So look what I'm left with. Decimeters cubed of HCl. HCl decimeters cubed. The only problem is the question said how many centimeters cubed. So I'm just going to go one more step. And 1 decimeter cubed is 1,000 centimeters cubed. And you wouldn't necessarily have to write this out, but I'm going to just to show you we can do it all in one problem, one step. And now these cancel, and now I'm really left with what I want, centimeters cubed of HCl. So when you type this in your calculator, and I'm going to get 3 sig digs, I get 863 centimeters cubed of HCl. So that is how you can use concentration as a conversion factor to solve stoichiometry problems with solutions.